Now, what is the state of, if the collar starts from rest at B? At A, it will have a speed V. Now, what is the state of, some more information is there here. Having is undeformed when the collar is at A. What do you mean by undeformed at when the collar reaches A? This is the natural length of the spring. So we know natural length of the spring, how much it is? L0. And this length is given 5 meters. So what is this R? R will be 7. Okay, fine. This R. Now, can we get the elongation of the spring? What is the elongation of the spring? R minus L0. That's what he mean to say here, no? Now the spring force will act here. So what this spring force will make it to accelerate? Then is asking, what is the normal contact between the collar and the ring? This is the ring. When the spring becomes horizontal. This much is information what we have. Any spring force will act here? No, spring force will not act here. Then who will provide it to move? I think normal contact in what direction should act? Towards right, towards left. I want answer from student. Here the normal contact in what direction you're going to show it, right or left?
Left, sir.
Right.
Left.
Right side, sir, because the spring force will pull it towards left, sir.
What is the spring force here? 0, no. Natural length. No spring
Both
force
the
is acting.
sides.
How come both the sides? Here I'm asking at A. It's a very serious question. Everyone has to put effort. That's what the numerical is. Here, how to show the normal?
It should be rightwards, sir. Towards the center.
Okay, that one. Yeah. Any other answers? Many
Sir,
are
it will
given.
come through us.
I just want here normal contact. What direction I should show it? Oh, many are not analyzing here the normal. The spring. What is the spring force? 0, no. Then who will provide required centripetal force? Normal contact. We will provide required centripetal force, the normal contact only. So the end should act towards right. If the spring is elongated, then spring force will act. Then also n minus kx. So altogether it is moving in circular path. No, somebody should be there. Somebody should provide centripetal force. So now the normal contact should be like this. Means the ring at point A. If this is the So the ring is going to be in this particular situation. You should draw such a diagram, sir. This was the normal content. The ring will exert on the force on the collar. I have to show like this that I'm not interested. Already we have discussed somewhere in the circular motion. This is a ring. This is at point A. And it will have a speed V. Fine. So
Sir,
you
but
should.
the spring force is 0. So who is pulling the ring towards the left, sir?
Have you never pulled any objects, man? The way you are asking question. Never seen any object being pulled. Spring force will normal contact here only it lacked here. So spring force will be gradually pulling it. It will get accelerated. Only at point A, I'm showing it N and spring force is 0. Here, spring force will be non-zero. Please understand the question. It will move like this, no? As the ring starts, as the collar starts moving, spring force, what will happen? The deformation, the elongation of the spring will decrease. Agreed? Spring force will become 0 because this is the natural length. Afterwards, what will happen? Again, it will get elongated.
Yes, sir.
not analyzing, only looking at B and A, what will happen, how it will move is supposed to analyze, no. The collar will move like this, the spring force will make it to move. At this position, what happened only at this position, sir, can you tell about normal reaction here? Okay, that one. Okay, put spring here. Spring force will act. The spring force will be acting, component of spring force will act in the direction. Still it's moving circular path, so normal contact should act towards center only. Then N minus component of spring force will provide required centripetal force. Here only normal contact providing centripetal force. It moves along the ring means centripetal force must be there. So N minus component of spring force. Here spring is relaxed, so therefore no spring force will act here. Making observation, very, very important. Okay, now whatever the weight will act into the plane of paper. So what all the elastic potential is stored in the spring will get converted into kinetic energy of the ring here. How to get X? We have information like this. What is L0? L0 is 7 meters. So we'll write the equation now. Kx square by 2 should be equal to mv square. What is the normal reaction? mv square r. I think manageable. Now, sir, I don't like this conservation of mechanical energy, sir. Like, what about work done by normal contact will be 0, no? Because any reason? And will always act perpendicular to the velocity. Okay, no, sir, I didn't like this work energy theorem or conservation of mechanical energy. I don't like it. I'm very good in kinematics. Can you really solve this? Look at the spring force, magnitude varying, and also the angle also varying. Very difficult to integrate. Huh? So therefore, the energy method is what is going to help us a lot.